Hello. In this lecture, we are going to discuss about how to do mapping using GIS. We will discuss in detail about data symbolization and visualization. Cartography is the art and science of making maps. And you know that map is a spatial representation of the environment, and maps are always simplifications of reality, which will aid the decision makers, even the general public, to understand the spatial patterns and explain the spatial patterns. And it is an effective communication tool, especially if you want to explain the spatial patterns. Maps are designed by people who has some intentions and who want to communicate about a spatial environment, so that they will create map responsibly using the principles. So such principles we will discuss today. If you look at this map, which is prepared or designed by a Chamber of Commerce, and they proposed a route, new connector route between two highways, considering the property values, because if they do connection through these areas and they have to pay much because the cost of land, rather the cost of land here or property is low here, so that they would like to construct a new connector using these low land or low property value areas. But other community group condemns the connector because it passes through them and it will divide them, it will divide their community into two halves, and they are opposing because it's going to affect their community. The group of historians argue that this is the area where you could find more historical properties, so the new connector will disturb them, like they are arguing the map. The business association also argue that the proposed road will affect their business because it is much away from their business district or business area, which means each map is by a different creator and each of them trying to convey a different message, and each map is good for a different group. So that's why the map is always the choice of the creator, who have some intention or who has some message that he want to communicate with the general audience or particular audience. Hence, for effective mapping or preparation of good maps require always some fundamentals. These are all the fundamentals we will discuss one by one. The first and foremost important of any map is the objective, what you want to convey, the message, and to whom you want to prepare the maps, or to whom you want to address through the maps, or to whom you want to communicate through map. So the audience also equally important. So the message and audience are most important for any map making process. Of course, not alone these two aspects, even other aspects also important. And one of the other important aspect is the data, because you have some message, you have some audience, and you have to prepare a map, but without data you can't prepare a map. So geographical data is also paramount importance, and you can't show data as it is, rather you have to convert data into codes. We call it as signs and symbols. So you have to pick relevant signs and symbols for your data so as to convey meaningful information. And of course, your map should be in a proper format. When you communicate through map, an audience should be able to understand the important elements from your map. So the essential components of layouting you should understand and you should incorporate in your map. And also important to understand on which media you are going to prepare or distribute your map, whether printed media or digital version. If it is printed media, what is the size of media, the size of printing sheet, whether it is a smaller or bigger. So depend upon that, you have to redesign or pick the relevant signs and symbols and appropriate map components. And if it is digital version and a live version like a Google Map, and you have to also think about or understand what kind of graphic software or what kind of web platform you are going to use, whether it is a static or dynamic. Dynamic means what are the attributes you want to show. In hard copy map, you can't show all the attributes, but in soft copy or digital format, you can show attributes as well. So if it is digital format and you have to think it of how best you can show the attributes in what manner for which what software or which platform is good. All you have to design well in advance. So the map designing is a continuous process, and it starts with collection of data or assembling the data from multiple sources. And next phase is analyze the data and convert the data into information, and then information to be symbolized using appropriate signs and symbols. And the symbolized information should be put in a proper layout with title of the map, legend, scale, arrow, source, and etc. And even labels also you have to add to explain easily about the different places and different locations, different information, and you have to make it the final. So it starts with data assembly and move to data into information and symbolization, and it finally come out with the proper layout. So this is, we call it as map designing process. We will discuss this designing process, the each stage in detail. Let's start with the data. So once you collect data from multiple sources, and you have to understand how to visualize it. Already we discussed about the geographical data can be discrete and continuous, and these discrete and continuous geographical data can be represented either point, line, or area entities, using point, line, or area entities. Of course, you have vector model and raster model, and depend upon your geographical data nature, whether it is a discrete or continuous, and you have to choose the model, and within the model depend upon the information. If it is one-dimensional information, you can use line. If it is zero-dimensional information, you can use point. If it is two-dimensional information, you can use area. Even you can add volume also and make it your data into three-dimensional. So once you choose the discrete approach or continuous approach based on your nature of geographical data, then you can decide different symbols. If you are choosing a vector model and you have a wide variety of variables, visual variables and graphical variables, you can differentiate your data, geographical data, in terms of point, line, and area, and within point you can differentiate the distribution using size or pattern or color, or within color again you can add saturation, and also you can use different shapes, different orientation, different color with shapes, so that you can make your data in a diversified symbols, depend upon the nature of the data, depend upon the communication or message you want to convey. This is applicable to even line entities and area entities. If you look at this map, you can't understand easily anything from this map, although it uses wide variety of symbols what we see here, but it is not properly picked up to represent the data or represent the information. So you have many choices of symbols, but how you are using, how appropriate it is, it's very important. The same data is represented in this map using other symbols or appropriate symbols. Now you can able to understand more and more information because it's clearly convey the message. So you have different symbols, and depend upon your message and audience, you have to choose the proper symbols for convey your message. This is very important, picking the right symbol for your data. This is applicable to even raster data also. And of course, raster data are symbolized differently from vector data because raster data normally uses the continuous information so that you can stretch your data using grayscale or color scale, or if data you want to represent differently, different groups without any like association, say for example discrete land use classes you want to, then you can use different colors for different pixels or different group of pixels. And if you have continuous information but you want to show into some classes, then you can classify your data and you can use appropriate colors. Now I have data and I want to show each pixel in a unique manner. Then you can assign color for each pixel so that you can able to differentiate all the pixels using the unique values approach. Sometimes you can use vector field also over raster data. Just create vector graphics over your raster data, like the arrows or direction of flow, etc. And you can show. Whether it is a raster model or vector model, you have nature of data that is discrete or continuous. So mostly discrete approach used for qualitative data. If you have a qualitative data and you want to represent each group or each class or each entity separately, then you can use different colors or random colors, you can say. But whereas if it is continuous data and you want to represent in a sequential manner or diverging manner, and you have to choose the color appropriately. So choosing color or hue or choosing the grayscale, it's depend on what kind of data you have and what kind of information you want to project. So for example, if you look at this map, the purpose of this map want to show where the highest internet users are. But using this discrete approach, random colors, it's very difficult to identify in which part of the world the internet users are high. But whereas if we use in a sequential manner the same data using a sequential color approach, you can able to easily understand which part of the world has the highest internet users. So this is more powerful than the discrete approach because the data is continuous. And even you can use diverging approach also, depend upon your purpose. My purpose is not only show the highest internet users, but also I want to highlight where the lowest internet users. So you have a two end, one side highest, another side lowest. So depending upon your objective, then you can use diverging principles or diverging colors also, so that you can highlight both information very clear. So depend upon your objective, and nature of geographic data, and you have to choose appropriate symbols. The most commonly used map type is choropleth. This is an example of choropleth using polygons and colors, where the spending per student by school district is represented using a diverging approach. One side you have a lower end, the spending is very low. Other side, the spending is very high from the national average. So both the information you can able to easily understand where the spending is low, where the spending is high at a glance. So this approach using colors or using some graphics, if you are preparing a map, that we call it as a choropleth approach. This is most commonly used map. In this choropleth map, two things are important. One is how many classes you are representing. So for example, here if you look at, you have 5 classes. So how many classes you are representing and what kind of classification method you are employing. Naturally, most of data have more information, wide range of information, and you can't show all the range of information. Rather, you have to combine those wide range of information into some handsome number of classes, maybe around 5. To make optimal number of classes, and you have to employ any classification method. There are 4 major types of classification methods, which includes equal intervals, quantile, natural breaks, and defined intervals. If you want to show all the classes with equal ranges, and you can apply this one equal interval. Say for example, I want to show the temperature into some classes of Fahrenheit, 50s, 60s, 70s, so that I want to show all the classes equal. Or else I want to show my data based on the statistical distribution. Say for example, based on standard deviation I want to show. Then you can use quantile approach. Sometimes your data may have wide range of values with some natural breaks in the data. You have different classes but with unequal intervals. So in such case, you can use natural breaks, or else sometimes you can do a manual approach irrespective of the statistical distribution. Say for example, I'm preparing a map to show the earthquake intensity. An earthquake intensity normally prepared based on Mercalli scale or Richter scale, and both the scales are defined scale. So you have to use the same scale as it is. Then definitely you have to go ahead with the manual scales. So like depend upon the objective and data distribution, and you can choose any one of these classification methods. Here, if you look at the data is same in all the maps, but the approach adapted for classifying these maps are different. The first one is using natural breaks, depend upon the breaks in the data, and the class intervals are fixed. It is unequal. See here the class distribution is less, here the class distribution is high, but here the number of counties or number of like units are high. So in order to have a balance of both the data distribution and data like frequency, and this natural breaks approach identify the proper class intervals, and accordingly it is represented. This one uses the statistical distribution using the mean. This is the mean, and below the mean 2 or 3 classes, above the mean 2 or 3 classes using quantile approach. And this one just simply uses the data into equal interval. All the classes have equal values. But if you look at equal values, majority of most frequency classes are clubbed into 2 classes, which means all data, most of the data formed under 2 classes. So it may not give you appropriate spatial representation or spatial pattern compared to the natural breaks. So this natural breaks approach may be appropriate for displaying the percentage of population over 65 years. And this is way we have to decide. You can prepare in a different classification method, and you can compare and contrast, and you can decide it, which class interval method is appropriate for representing your message. Once you symbolized your data, then the final step is layouting. We call it as map layout or map designing. It is about developing a balanced arrangement of different map elements, including title of the map and the main information and scale and labels to represent different units and coordinate information and source of data and so on. The map designing is based on majorly three questions, that is, who wants the map and what they want to see and what is its purpose. So depend upon answer to this question, you can design your map layout. And sometimes the purpose of map is very general maps and general public. And sometimes the purpose of map is to specific group of people. They want more scientific information. So depend upon that, you have to choose the elements, which elements are important, especially for general purpose map. For general audience, you have to maintain all the map layout elements so that they can able to understand the information very clear. Say for example, the directional symbol. I want to like explain or interpret this map. So whether the eastern part of this area or western part of this area is high, or northern part of this area or southern part of this area is high. If I want to concretely say like this, and I should know about what orientation the map is. So for which adding the directional symbol is very important. And this purpose of map is to explain the general audience the mean value of chikungunya prevalence, a particular vector-borne disease. And the mean distribution state-wise, if I want to show it in addition to the classes, exactly the mean values I want to show it, and you have to add it as a label. So depend upon your purpose and for whom you are preparing this map, and you can add the elements appropriately. Sometimes the inset or locator maps also required, especially to reach out to wider audience. So where this area is located in the particular continent or in general in the globe. So for which you can add inset map and you can place it at appropriate location. Normally the map is prepared with the central data. The central data is this area. So once you symbolized this like a central information around which you can construct a boundary, and within gap between the central data and your boundary, and you can add other elements. Say for example legend, wherever gap exists you can add. You can add inset map, you can add the directional symbol, you can add a scale, you can add a source without affecting the central information, because central information is very important. So add the central information and insert the associated map layout elements at appropriate location. And also important that you have to fill all the gaps. Okay, say for example, you can put this north arrow here also. The scale also you can put somewhere here, but this area left blank. So in order to avoid such, you have to judicially utilize all the empty spaces so that It will not look like a clutter, rather it look distribution of all the elements in an optimal way. Although many people nowadays using GIS preparing various maps, and they are encountering many common visualization problems. All those problems are listed out here. The most important or limitation of majority of the maps is identifying the wrong audience or underestimate the audience. So sometimes you are preparing map for general public, but the map may be too technical. The general audience could not able to understand what you want to or what you are trying to convey. So you have to identify the audience properly to whom you are preparing map and what would be their level and how much information they could able to grasp through your map, and accordingly you can generalize your data and you can present it. And second most important problem is choosing inappropriate symbols and colors. Sometimes you may be picked out the data properly or you used proper models also, vector model and raster model, but if you are not using appropriate symbols and colors for your model, vector and raster model, then it may not reach properly your message. So you have to choose appropriate symbols and colors. Sometimes your symbols and colors, what you are seeing in your computer or laptop may be good, but when you go for printing out using plotters or printers, and you will get a different color. So this happens in most of the situation. And sometimes some of the colors may be printed well, and some of the colors may not able to get properly using the printers or plotters. So such colors you have to identify and you have to avoid it. What best color can be produced through printer and plotter, that you have to choose it. Normally the primary colors and secondary colors are produced in a better manner compared to other tertiary colors. So these three are very major problems, visualization problems. In addition, and sometimes people overemphasized the information, add more information, more like labels, more what you call like elements all into the map and make the map more clutter and make more detail with the restricted or limited scale. So depend upon scale, you have to choose your symbology and annotation. Say for example, if it is a large scale map, you can add a street name, no doubt about it. But if it is a small scale map, you can't add it such. And even if you want to say for example highway, you want to represent the highway number, in one or two places you can use the highway number, not at frequent locations or every road section, because it will add more detail into that and affect the data behind it. So depend upon scale, you have to decide it, how much symbology can be added into it and how much labels or annotation can be added into the map. And sometimes you did proper symbology and proper annotation, but the necessary map element may be omitted in the final map. Say for example, without title and just you presenting, or without scale you are presenting. And sometimes north arrow is very important, because in interpretation you mentioned that left part of this area have high or low, right part of this map have high or low, but they don't know the left and right part. Even left and right sometimes understand, but if you are using the word like east or west or south or northeast, then it is very difficult for them to understand which direction the map represents. Especially if you are preparing map to explain the directional information, then the direction is very important. So the map should not have any omission of necessary map element, and that also a common map visualization problems. So if you address these problems, and your map will be effective. With this, I just stop the lecture. Thank you.